Thank you for joining us today. I'm excited to be sharing a story of our journey migrating and optimizing Infor's pricing and billing solution. We're going to be taking you through our decision-making process and the challenges that we faced while going from on-prem to cloud in AWS. Hi everyone, I'm Brandon Blinko, and I'm a Senior Solutions Architect here at AWS supporting financial services customers. I'm joined today with Amir Satude, who is a Microsoft Specialist Solutions Architect, and Brad Schaaf, who's the Cloud Architect at Infor. We're grateful to be here today, and it wouldn't be possible without all of our teammates at Infor and AWS that supported this initiative to be able to create this story so we could share it with you today. During our time, we'll break down our decision-making process, how we chose to go about the migration. We'll also be talking about optimizations that we needed to make to be able to meet the performance requirements necessary for this particular application. And I want to just say that these steps can be generalized to many Microsoft applications, so I hope that you'll take something, one or many things from this talk, and use it in your next migration and optimization play. Infor's pricing and billing solution is known as Complete Billing System, or CBS, and it's a batch processing application primarily based on the Microsoft stack. Many of the components of this solution are built with C# and the .NET framework. It also includes a SQL Server as well as the Windows machines. Identity and authentication is with Microsoft Active Directory, and they have a custom-built security token service. And one thing you'll probably notice is this is a very common application profile for Microsoft applications in financial services. So just a quick show of hands, how many of you are with a financial services company? Awesome. And how many of you have Microsoft applications that you're looking at? Perfect, great. So you're going to be familiar with this. So pre-cloud versions of CBS, they followed a perpetual licensed self-hosted model. So banks would purchase CBS from Infor, and then they would be responsible for installing the software in their data centers. This meant that the banks were fully responsible for managing that application during its life within that data center. This includes things like patching, maintaining compliance, security, as well as scaling over time as the demand increases. More recently, banks have shifted to embracing the cloud as part of their business's strategic plan. This includes moving Microsoft-based applications as well. They want to go back to focusing on, and I'm sure some of you know, focusing back on their core business, which is banking, and not on undifferentiated heavy lifting such as hosting. They see the cloud as a strategic enabler for keeping up with the ever-changing regulatory compliance environment that they work in, maintaining the highest levels of security for their workloads, their data, their network, competing with nimble new entrants to the marketplace, being able to constantly keep up with right-sizing their infrastructure so they're not over-provisioned and they're not under-provisioned. And last, breaking down data silos and modernizing legacy systems so that they can take advantage of innovative technologies, especially now with the new AI/ML capabilities that are coming out. At AWS, we continue to see banks moving their Microsoft workloads to the cloud. Infor's customers were explicitly asking for a cloud version of CBS, and this created an opportunity for us to start working together and be able to share this story with you today. To start our migration journey, really to start any migration journey, the first thing you may think about doing is building the architecture diagram. What is this going to look like on CBS? But I would say we actually have to take a step back and ask ourselves some questions before we get there. And there's really 4 key questions to consider in this particular case. 1, how are we going to handle identity and authentication in the cloud? 2, what are we going to do with our data? 3, where are we going to deploy and run our applications? And 4, what are we going to do about licensing? So now that we have these questions that we can ask ourselves, what are our options when we run on AWS? First thing to think about if we go back to that first question is, what are we going to do with Microsoft Active Directory? Many of these applications are using that for identity authentication. What about SQL Server? Can we run it in the cloud? How about our .NET applications? Where are we running those? And finally, Microsoft licensing. Can we bring existing licenses? Or is AWS providing licenses? How does that work? I'm going to go through these very more generally, but when Brad comes up, he's going to talk specifics about the constraints and requirements that we had from a business and technical perspective with CBS and at Infor. As you'll see later, the decisions that we make have a direct impact on CBS and Infor's ability to maintain security, performance efficiency, reliability of the workload, and cost in the cloud. So let's start with Microsoft Active Directory. When it comes to AD, one of the first questions you should ask yourselves is, do I want to manage infrastructure, or do I want to look at a managed service? If you want to move towards a managed service, there's a few things that you need to consider to make sure that it's not going to become a blocker for your migration. You won't have the same level of control that you would have without a managed service. Things like domain and enterprise admin access, you will not have. You have no direct access to the domain controllers themselves through a remote desktop protocol. So that's really important. Another thing is you can't create users in the domain and enterprise admin groups. And last, if you have special situation where you're installing agents on those domain controllers, or maybe you have special configuration for your SQL Server, this may not be a right fit for you. Last, if you have a very large deployment, there's a hard limit for the managed service of 500K objects. This includes computers, service accounts, users, and so the managed service may not be a good fit in that case. But it is possible to also use or self-manage on Amazon EC2. And this, if we think about what I just mentioned from a constraints perspective, this is the opposite. If you do have a situation where you need to install agents, or you do need to have some more control, this will give you the option to be able to do that. And lastly, if you want to span from on-prem to the cloud, managing it on Amazon EC2 is an option for you. What about database? Can we run SQL Server on AWS? And the answer, some of you probably already know this, absolutely. And there's a few different flavors for this. There's three options for us. The first is a managed offering, where we can run it on RDS from SQL Server. Another option is we can run it on Amazon EC2. But the third option gives us a middle ground where we share responsibility. AWS can handle some of the high availability, and you get some of that configuration that you might desire with RDS Custom for SQL Server. Each of these options have their own limitations, including control, licensing, and management overhead. Next, let's talk about where we should run our .NET applications. This decision is really twofold at the most basic level. Do you want to have a little bit more control and have more management overhead, or do you just want to get your application code up into the cloud and not have to worry about the management overhead? So oftentimes what we'll do is we'll look at the left-hand side of this for situations where maybe the migration is risky, the developers have since gone and you're just trying to get the code up and you can't change it, or maybe you just want to move to the market quickly. AWS Elastic Beanstalk and Amazon EC2 are good options to get started. For Windows and SQL Server licensing, there's three options we can consider. We can buy a license-included instance, and you get you only pay for what you use. So when you spin that machine up, you pay for the machine and the license, and when you turn it off, you're no longer paying for that license. There's also options for bringing your own licenses. There's two different options here. The first is that you have license mobility benefits with your license. This allows you to run on an EC2 instance in shared tenancy mode. And the other option is, if your current license doesn't have license mobility benefits, you can still bring that license to AWS running on a dedicated host. Now that you have a foundation of the questions we have to ask ourselves, some of the options that we have available to AWS, I'm going to bring Brad up on stage to talk to us about the specific constraints around business requirements that we had to work with this migration.
Thanks, Brandon. Hi, everyone. My name is Brad Schaff, and I'm a cloud architect at Infor, and I specialize in our CBS system, the complete billing system. First, I'd like to introduce you to CBS, which is used by commercial banks. And these are specifically commercial banks that offer treasury management services to their large customers. So you can think of these services as things like ACH transfers or writing a check, wire transfer, lockbox services, all sorts of other different types of services. There's a lot of them, up to like 2,500 different types of services. So traditionally, when banks are managing all of these services, they price them separately. And this leads to really fragmented customer experience because the bills that the bank will get don't really give them a complete picture. So what we want to do with CBS and what we do with CBS is provide a unified pricing strategy with all sorts of different options for the bank to encourage more behaviors like using more of the services and utilizing different types of services than they may be using today. So using CBS, they can move to a single global consolidated billing statement. Now, it's important to note that CBS is not what you would think of as a traditional banking application, which are usually transactional in nature. CBS is a batch processing system with a front-end UI to allow you to management. Now, we can intake data throughout the day, but where CBS does all of its work is at the end of the month when it generates that monthly consolidated bill for that specific bank's customers. Now, all of this is much more difficult and requires a lot of compute, and we'll get into that a little bit later. So a little background on Infor will help you understand some of the decisions I'm going to walk you through that we made. Cloud computing is not new to Infor. We are a global leader in cloud-based industry-specific offerings, and we have our main offering is called Cloud Suite. Within Cloud Suite, we have both single-tenant and multi-tenant options. So for a lot of reasons I'm not going to walk you through today, we decided to onboard CBS into our single-tenant offering. We initially developed and took a rehost strategy so that we could basically lift and shift our workload into AWS. That allowed us to do a lot of different things like focus on a lot of our code changes later. We could just pick up what we had and put it in the single tenant offering. This allowed us to move quickly. So even though we wanted to move quickly, I wanted to take advantage of some cloud native services if it made sense, if there was a good reason to. So along our journey, we looked at a lot of AWS services and a lot of Cloud Suite services as well. So since we're at AWS reInvent, I'll focus on more of the AWS services and not bore you with the Cloud Suite ones. So personally, I prefer as an architect to utilize a service instead of managing servers. It allows you some more flexibility down the line, gets me out of the business of worrying about IP addresses and servers and everything. I can worry about, is the service performing? So we chose initially to use Amazon EC2 for our instances on virtual machines. Again, per our rehost strategy, that was the simplest decision. So properly sizing those EC2 instances is what we spent most of our time on. And later in the topic today, we'll have Amir come up and talk to you a little bit more about that. So one of the first AWS services we looked at was AWS RDS. You know, if we use this service, we could get out of the business of managing SQL servers and backups and all of this. What we found was our Cloud Suite team already had this pretty much well in hand, and they were efficiently managing SQL on EC2 instances in our single tenant environments. So even though we got CBS working with RDS, and it worked very well, it was very simple to do, we decided that our environments at this point weren't really ready to fully leverage RDS, and we're going to take that as a future objective. So the next thing we looked at is managed AD, Microsoft Active Directory. And as Brandon walked you through, we don't really have a lot of objects in our directory, but we did need access to our domain admin groups, and we needed access to the domain controller specifically for some things that our application did. So this is also one of the decisions we made. We're just going to run Active Directory on EC2 instances as they do today in our single tenant environment. So the next decision was licensing, and licensing is always a big decision. While Infor has a lot of Windows and SQL licenses that we could have spent a lot of time provisioning and allocating across our offerings, we decided that we did not want to take that work on just yet. We may look at that in the future. So what we did is we went and used the Windows licenses and the SQL licenses bundled with those EC2 instances. And that gave me a lot of flexibility. I don't have to worry about licensing right now. I can worry about getting everything sized appropriately. The other thing it does for you is if you have environments that aren't going to be running 24/7, right? You have some development environments you only want running 8 hours a day, or if you have a failover or disaster recovery environment that you're going to run once a month, you don't have to pay for a full license. You're only paying for those licenses when they are running. So we chose to use the licenses included in Windows and SQL. Now, let's get into the core challenge that we had. We needed to hit some specific SLA targets. We are a batch processing system, and our biggest day is at the end of the month, and it's called lead night. Now, we deal with a lot of different sized banks with different sized environments, and because we're on AWS, we can scale up and down, but we needed to know where to start. So we started with something I use called a t-shirt sizing metaphor, and we defined small, medium, large. We also have extra large, and as you can imagine, XXL, and you can put as many X's in front of there, and we have those. So we picked just our large workload to start. And we focused on the servers that were going to be doing most of the work. And those are our batch processing servers and obviously our SQL database servers. So on lead night, it is amazing how much processing we have to do. And we'll get into that in just a bit. So we focused on that large t-shirt size. We needed to process 1.5 million accounts, and those accounts had 110 million transactions. So our SLA for this, our typical SLA for this, is to get this done in 8 hours. Now, that sounds like a lot of time, but those servers are very busy during those 8 hours. The problem is when we took our large workload, dusted it off, wound it up, and let it go, it finished in 12 hours. So we knew we had some work to do in this large workload. So we wanted to reduce our processing time by 33%. So we teamed up with our AWS partners, and the first thing Amir and Brandon asked me for were, hey, we need some benchmark data. We need some of your existing performance benchmarks. Well, the problem is all of our customers before we had the offering were on-prem. We had no idea what they were doing in their environments. We didn't know what server sizes they were running. We didn't know how they, compared to the profiles you can run in EC2. So I simply challenged Amir and Brandon to help us with this. We needed to reduce 33%, and I gave them the further challenge that we were going to make no code changes and no platform changes. So no code changes to speed up anything, no platform changes to move from SQL Server to something else. And with that, I'll hand it over to Amir.
Thank you. March 7th, 2022. That is the date I officially became a solutions architect here at AWS. Hasn't been a long time, just under 3 years, but long enough for me to have had a chance to work with more than 100 solutions architects. That, coupled with the fact that all three of us speaking today happen to be solutions architects, made me think it might be a fun exercise to start today's session with a quick game of 2 truths and a lie about solutions architects. As solutions architects, we seem to truly believe that anything is possible, given enough time and resources. Now, I, for one, would never try to prove a solutions architect wrong on that one, because they can always come back and ask for more time, more resources, or even both. Number two, when you ask us a question, we feel kind of an obligation to respond with two magical words. And those two magical words are, it depends. Now, I understand that some of you might think that's because whenever we don't have the answer to your questions, that's our go-to answer. But I'm here to tell you, do you know what's even more dreadful than not having the answer to your questions? It's giving you the wrong one. And number three, solutions architects, and specifically specialist solutions architects, know everything about their specialty. Now, before I confirm your preconceived notions about the SA community, I'd like to tell you a story. This is actually a true story of the very first time that Brad, Brandon, and myself met. I remember vividly where it all started. I remember because I was lucky enough to be working remotely out of a cabin 2 hours north of Los Angeles at a place called Pine Mountain Club. I remember as I was sitting on that white chair when Brad talked to us about Infor CBS for the very first time. We talked about their plans for moving Infor CBS to AWS and offer it as a SaaS solution, and of course, the challenges that they faced along the way. I remember as we were wrapping up the call, Brad said, Amir, do you have time for one last question? And I look at the time and I know I had to jump on another call, so I go, well, you know, Brad, it depends. Is it a short one or is it gonna take a while? And he said, it's a short question. And he continued, knowing what you know now about Infor CBS's architecture, do you think it's even possible to cut our batch processing time by 33% without touching the code and without changing the platform? I remember thinking, God, I know there are ways to optimize SQL Server's performance. I know my colleagues do this day in and day out, but am I the right expert to be able to comfortably say yes to that question? The answer was a resounding no. So I collected my thoughts and I go, well, you know, Brad, it depends. Anything is possible, given enough time and resources. Now, by now, you all know my name, and you know I am definitely a solutions architect. And if you were paying attention, you also know I did not know everything about SQL optimization. And if I'm being honest with you, I did not know anything about SQL optimization. Yet here I was, tasked with helping the Infor CBS team doing exactly that. And I will not share the exact results with you just yet, but I will just say it was a successful exercise, or else I wouldn't be standing here talking to you about it. So for the next 35 minutes or so, I will do everything and I will try everything to give you enough reasons. So by the time you're walking out of this session, you will seriously consider performing a similar exercise for your own workloads, because there is a lot to gain with a reasonable amount of time and resource investments. As Brad said, at this point in the process, optimizing the performance of Infor CBS was the most important challenge on their way to be able to offer it as a SaaS solution on AWS. So as a non-SQL optimization expert that I tried to come up with some kind of a game plan that would help me help Infor CBS team. Now, the first step was rather an easy step to come up with. That is actually a kind of a step that we are continuously reminded of and encouraged to take with any customer engagement at AWS, and that is starting with the goals and constraints. Now, this is where I believe at Infor CBS team, the leadership team at Infor CBS did a really great job, because they actually were able to come up with just a few crisp and clear goals so that the team would be focused specifically on those goals. And as you have seen this already, the goal was cut the batch processing time by 33% without touching the code and without changing the platform. Now, starting from goals and constraints lets you lay out the ground rules for your right-sizing recommendations. In Infor CBS case, we wanted to make sure, number one, all the performance metrics that we were capturing from running Infor CBS were well within the published ranges of EC2 services. Number two, as you heard it already, no code change, no platform change. And number three, we had to do all of that in a cost-conscious manner. So what is the next step? If you think about the core of our assignment, we had a handful of decisions to make around the performance of Infor CBS. We had to decide what kind of an instance should we run on, what kind of a storage should we pick. Now, each one of these options would inherently come with a certain amount of limitations. And the way we could measure those limitations was through some performance metrics. So we decided to work backwards from the performance metrics that would help us identify and measure the limitation of the options that we were picking. So next step, knowing your metrics. Now, at a very high level, there are 3 different categories of performance metrics that we are going to talk about today. You have seen the general category before, things like CPU utilization, memory utilization, and so on. Then there are some more nuanced performance metrics, which are specifically around the storage, which I will spend a little bit more time on to explain. And then you have some application or SQL Server specific metrics. Now, I'm going to try to use an analogy for the storage performance metrics that we will be talking about, because I think it will help visualize some of those concepts. If you think of your storage as a two-way road with cars traveling in both directions, IOPS, or input-output per second, would be the number of cars passing a certain point on that road at each second in both directions. IO size would be the size of the car. Think of it as the number of passengers traveling in that car. Now, throughput in that analogy would be the total number of passengers passing a single point on that road in every second. Now, what happens when you reach your IOPS or throughput limit? You can think of it as a road that is narrowing. What does a road that narrows cause? It causes a traffic jam. Now, volume queue length in that analogy would be the number of cars waiting in traffic to pass. So next step is actually thinking about what kind of options we are dealing with. If you think about all the resources that are available to a SQL Server environment, it's going to be what kind of compute you have, how much memory you have allocated to that environment, what is your network throughput, and of course, your storage options. Now, 3 out of those 4 type of resources available to your environment are governed by your instance type. So logically, one of the most important decisions that you will have to make in order to get to a performance environment is going to be the instance type that you select. Now, storage is a decoupled service on AWS, meaning you get your different options independent of your instance type. But still, the choice that you make for your instance type will have some impact on the type of options that are going to be available for your storage as well. So let's dive a little bit deeper on the type of storage options that are available to you. Going back to the same analogy that I just talked about, imagine what kind of roads are available to you for your daily commute. You have the city roads, which are perfect for your regular everyday traffic, and you will have highways or freeways that are designed for a higher speed and maintaining a consistent flow. And in the far right, you will have specialized track races that are designed for maximum performance and high-speed intensity. Similarly, on AWS, there are a couple of options in terms of volume types available on EBS, or Elastic Block Store. You have general purpose SSD. This is your typical everyday storage. You have IO2 and IO2 Block Express. Now, the key to remember about IO2 and IO2 Block Express volumes is that they are called provisioned IOPS volumes, meaning you can allocate IOPS and throughput to those volumes independent of the size of the storage itself. So let's take a quick look at the performance differences across these different volume types. From IOPS perspective, you can think of it as the speed of your storage. GP3 maxes out at 16,000 IOPS. IO2 would give you all the way to 64,000, and IO2 Block Express 256,000 IOPS. For throughput, both GP3 and IO2 volume max out at 1,000 megabits per second, and IO2 Block Express goes all the way to 4,000. And in terms of size, GP3 and IO2 both max out at 16 terabyte, and IO2 Block Express 4 times that at 64 terabyte. Now, all these different options that I just talked about are part of what I mentioned already, Amazon Block Store, Amazon Elastic Block Store, or Amazon EBS. Now there is a different type of storage that is also available to certain type of instances on AWS, and that is instant store volumes. The key about instant store volumes for you to know is these are actually physically attached storage to the underlying host. So you can obviously expect a higher level of performance from these kind of volumes, but the key to remember for them is these type of volumes are ephemeral, meaning you lose the data on those volumes within each restart of the instance. Now that makes them a very perfect fit for a specific use case on running SQL Server, which is for TempDB on SQL Server, but I will dive deep into that as we go through some performance tests. Next, knowing your limiting factor. If this is the speedometer of a car that you're looking at, theoretically, what is the fastest speed you can drive with that car? 200 miles per hour. How about now? Now there is a different kind of limitation that applies to the maximum speed you can get with that car, and that is enforced by the road you are traveling in. Similarly, you have to keep in mind when you're thinking about the performance of a SQL Server environment, there are performance limits that are being applied at different levels. There are certain performance limits that are applied at the EC2 instance level. There are some that are applied at the EBS volume level. And of course, there will be some that will be applied at the application, in this case, SQL Server level. Now, the key to remember in this specific topic is whenever you have a certain type of performance limit that applies at multiple tiers, keep in mind that the lesser of the two applies. Okay, now we're getting to the fun stuff. Test, right size, and repeat. Now, before you can actually start testing your performance, you would obviously need some kind of a monitoring system in place that you can actually capture the performance metrics of your workloads and see how you are doing across different tests. Amazon CloudWatch would be the tool that you can use. I am not trying to go through all the details of how to set up that tool. All you need specifically for this use case in terms of getting performance data from SQL Server would be a specific blog post that goes into the details of how to set that up. In fact, that was all I shared with the Infor CBS team, and 2 days later, they had the whole environment set up and we were able to start testing. So let's go through the tests, but before we go through the tests and how the tests came out, I want to quickly give you a guide and a roadmap of what I will share about each round of the tests that we did. You will see the instance configurations before we started each round of the tests for two main servers, the application server and the database server. We will talk about the goals that we had for each round of those tests. We will see what kind of findings we had after running those tests. And at the end, we will see what kind of recommendation we came up with after looking at those findings. So to start with, for the database server, we chose R6i 8XL instance type, and you can see the configuration that is there. Key to remember, a single GP3 volume with 16,000 IOPS and 250 megabits per second for throughput. For the batch server, we chose M6i 4XL, and you can see the configuration there as well. Now, question becomes, how did you come up with that initial configuration? That was a best guess scenario because if you remember, we did not have any performance metrics, so we had to come up with whatever environment we had set up, kind of a like-to-like mapping with the on-prem environment. So the goals for the first round of the test was, obviously, we wanted to benchmark the initial performance of Infor CBS on AWS and understand what kind of a workload we are dealing with. Is it more of a memory-intensive workload, or is it more of a IOPS-intensive or throughput-intensive workload? Now, what you will look at right now, these are actual tests and actual snapshots from the dashboard from CloudWatch for each specific metric, and you will see the name of the metric on the bottom right, and you will see the performance data for SQL Server in blue and for batch server in orange. Now, what you can notice right here from the EBS throughput standpoint, we had a limit of 250 megabits per second on our storage for both the volumes on both servers. Now, specifically in this case, you can see we are breaching that limit at 262 with the peak at the beginning, at the end of the tests. What is the finding? Obviously, we are breaching that EBS throughput limit. What is the recommendation? Let's increase that limit to 1,000 megabits per second for SQL Server and to 500 megabits per second for the batch server. Next, let's take a look at CPU and memory utilization for both servers. Now, as you can see, in terms of CPU utilization, we're peaking at 91.1% CPU utilization pretty much for a good chunk of the time that we are running the tests. In terms of memory, we are left with less than 5 megabytes of memory. So, as you can see, we are seeing a persistent CPU and memory pressure and contention on the batch server. So it makes us believe that we are basically outgrowing that environment for the batch server. What is the decision? Changing the batch server to M7i 8XL because one, we are doubling the CPU and memory, and number two, we are moving to the latest generation for M-series instances. Typically, whenever you get to the latest generation, you get something between 10 to 15% better price performance. Now, we also took advantage of a best practice. I quickly pointed this out about using instant store volumes and moving TempDB of SQL Server because it's a very good match for that kind of a workload. So that's actually what we decided to do. However, we had to change our instance type for the SQL Server to an instance type that did support instant store volumes, and then move everything for the TempDB of SQL Server to that volume. So let's go to the round two. You can quickly see what kind of changes we just talked about being applied to the configuration of the instances. Obviously, we moved to R6ID 8XL, moved the TempDB to NVMe or instant store volumes, increased to 1,000 megabits per second for EPS throughput on the SQL Server. And on the batch server, we basically doubled the CPU, doubled the memory by moving to M7i 8XL, and we doubled the amount of EBS throughput on the batch server. Now, the goals for this round, obviously, we wanted to address the throughput limit breach that we saw in round one. We wanted to test the effect of moving TempDB to these instant store volumes, and we wanted to see how the batch server would perform after doubling its resources in terms of memory and CPU. So in round one, if you remember, we were breaching at 262 megabits per second for EBS throughput. Now in round two, we are going all the way up to 833 megabits per second towards the end of the tests. What does that tell us? Obviously, it's relieved the pressure on throughput, and we are getting all the way to 833 megabits per second throughput towards the end of the test. So that was probably a good call in terms of increasing the EBS throughput on those volumes. Now next, let's talk about volume queue length. If you forgot, volume queue length was the number of cars in traffic waiting to pass. So in round one, we were peaking at 5.68 volume queue length. In round two, we got all the way to 17.9. So it seems like we have a lot of cars waiting in traffic. Whenever you see an increased value for volume queue length, you can think of some kind of a pressure on your IOPS. There is some kind of a limitation on performing more IOPS. So the peak volume queue length of roughly 18 shows some contention on IOPS for our SQL Server. Now, talking about IOPS, in round one, we peaked at 6,000 IOPS, and in round two, we got all the way to 28.1 thousand IOPS. Do you remember what was the maximum value for a single GP3 volume in terms of IOPS? 16,000. How on earth did we manage to get 28,000 IOPS out of a volume that had only a limitation of 16,000? Key thing to remember, whatever number you see in terms of the published ranges in terms of performance on AWS services, that is the guaranteed range that you can rely on. You might get better performance out of different services, but that's purely at the discretion of that specific service. That is not something you can rely on and plan for. So that was definitely something we needed to address. So increasing the throughput allowed us to complete more IOPS. Now we are breaching the IOPS limit. What is the recommendation? We decided to break the data and log volumes of SQL into two different GP3 volumes, 16,000 IOPS volume for each, And that would be our recommendation based on that finding. Now let's take a quick look at the CPU and memory utilization. As you can see, we are peaking at 85.6 CPU utilization for the batch server. We are running hot on CPU. It's not the end of the world. It's not at 100% for the duration of the tests. So that's perfectly fine for now. However, in terms of memory, we are still less than 4 megabytes of memory left on the batch server. What is the recommendation? Batch server seems to be, the finding is batch server seems to be memory intensive. We are out of the memory pretty much for a good portion of the time that we are running the test. Recommendation, let's upsize the batch server to an R7iz8XL, which is basically going to double the memory available to our batch server while keeping the CPU at the same level that it was. Round 3. Instance changes. You can quickly see what kind of changes we made. So on the database server, we just added an additional GP3 volume. So now you have two 16,000 IOPS volumes. On the batch server, we moved to an R7iz8XL, which basically just doubled the memory available on that instance. Now the goals for this round, obviously we saw a breach of IOPS, so we had to address that, and we are addressing it by adding an additional GP3 volume and breaking the data and log volumes of SQL. And we also wanted to test the effect of adding that additional memory on the batch server. So in round 2, we had less than 4 megabytes of memory left. We doubled the memory on the batch server. Let's take a quick look what happened in round 3. If you look at the peak of memory utilization, which is basically when we have the least amount of available memory on batch server, we still have roughly 128 gigabytes of memory available. So the additional 128 gigabyte that we just provided to the batch server was not utilized. What is the decision? Obviously, the finding is we did not utilize that memory. What is the recommendation? We don't need that memory. Let's downsize on that batch server and go back to R7iz4XL. Volume queue length. Round 2, 17.9. That was a single GP3 volume. Round 3, now we had two GP3 volumes. Please take a note that now we have the SQL Server logs and data being shown on round 3. But something interesting happened. If you sum up the volume queue length of those two different GP3 volumes, it ends up being the same roughly 18 value that we saw in the previous round. We basically broke the traffic into two different roads, but still we have the same number of cars waiting in traffic to pass. So the fact that it stayed the same is telling us we still have that contention on IOPS. Now let's take a look at IOPS. We got all the way to 32.9 thousand IOPS in this round. Even though we had two different GP3 volumes, they still max out at 32, and we are still breaching that maximum value. It seems like we just need a faster kind of a storage. So we decided to move everything to a single IO2 volume and simplify the architecture by moving the temp DB, the data, and the log volumes all into a single GP3, into a single IO2 volume, and set a 40,000 IOPS max on it. Why the 40,000? IO2 volumes could give us up to 64,000, but there are limits that apply at different levels. Our instance of R6ID and 8XL is maxing out at 40,000 IOPS at the instance level. So that's why we had to set it to 40,000 IOPS max. Now for context, when we started these tests, R7 families were available for us to pick for SQL Server. However, if you remember, we had a round of tests in the first round, and we came up with a recommendation to move the temp DB of SQL Server to instance store volumes. Caveat was R7s were available, however, they did not offer instance store volumes. That's why we started with R6s at the time that offered instance store volumes. Now at this point, we decided to move everything to an IO2 volume. We don't need that instance store volume anymore. So now we could actually move everything to an R7 because we didn't need the instance store volumes anymore. Okay. And round 4. Let's quickly go over the instance configuration changes that you just saw. So we have now on SQL Server a single volume with 40,000 IOPS. And on the batch server, we have doubled the amount of, we have cut the amount of CPU and memory in half by moving to an R7iz4XL instance type. The goals, addressing the IOPS limit breach that we just saw, and testing the effect of downsizing the batch server this time. Let's take a look. Round 3, we peaked at 86.7% CPU utilization with 32 cores of vCPU. In round 4, we got all the way to 89.7, an increase of 3% in CPU utilization, however, with half the number of cores on the batch server. So that was pretty much the right call. We just increased 3% on CPU utilization with half the number of cores. Now, in terms of EBS IOPS, round 3, 32.9 thousand IOPS that you remember. And in round 4, we went all the way to 38.1 thousand IOPS. That is the highest amount of IOPS that we completed across all of these tests, which is pretty much all the way to the limit of the 40,000 IOPS available on that instance type. Now, this is my favorite slide of all. I was literally jumping up and down when I saw this. In round 2, if you remember, volume queue length was 17.9. In round 3, we had 2 different volumes. The sum of them still stayed at roughly 18. Round 4, the volume queue length went all the way down to 6.3. That is 66% decrease in volume queue length. We basically cut those lines of traffic by 66%. Okay, now we did all of these changes, but how did it impact the original goal that we had? How close did we get to the original goal, which was cutting the batch processing time? If you remember, in the round 1, as Brad mentioned, we were just over 12 hours of time in running that process. And after round 4, we went all the way down to 6.5 hours. That is 48% time savings. Now, logically, we wanted next to make sure everything is performing within a very reasonable cost threshold. Whenever you're dealing with a SQL Server environment and you're trying to cut costs, the best place to look for is SQL Server licensing. Let me show you why. If you're running an R6ID8XL instance on AWS, it's going to cost you roughly $4,000 if you are running it on a Linux operating system. If you add the Windows Server licensing to that, that will go all the way to $5,000. If you add SQL Server Standard to the mix, that will take you all the way to $8,000. And if you add SQL Server Enterprise, that will take you all the way to $14,000 a month. So logically, that is one of the things that we worked with the Infor CBS team to evaluate, and thankfully, we realized they could live with SQL Server Standard Edition and downgrade to Standard to save on SQL Server licensing costs. Now, let's take a quick look at the outcomes of our exercise. As you just saw, 48% batch processing time reduction, that is 15% more than their original goal of 33% reduction. We cut 74% of their SQL Server licensing cost by simply migrating or downgrading to SQL Server Standard Edition, which resulted in roughly 24% total cost of ownership reduction or TCO reduction. I guess we can all agree by now that right sizing matters. If you upsize too much too fast or downsize too much too fast, the results are not going to be favorable and funny in some cases. Now, I want to share a few stats about the level of time and resource investments that Infor CBS team did. Do you know the amount of time that both AWS and Infor team spent on this whole exercise was less than 100 hours? Do you know how many times we had to throw out the results of our tests? You only saw 4 rounds of tests being presented here, but we actually ran these stats 8 times, and we had to throw out 4 of them because real world happens. We missed to reset a specific parameter or reset the data between the tests, so we could not rely on the result of those tests. And lastly, do you know how much it cost us to run, in terms of infrastructure costs, to run these tests on AWS? Less than a couple thousand. Infor CBS team did not succeed because they had a team of sophisticated SQL optimization experts that spends months and months and hundreds of thousands or even tens of thousands of dollars and got it right the first time. Infor CBS team succeeded because they were enabled to fail, but they were enabled to fail fast. They were enabled to fail often. They were enabled to fail cheap. And I think the greatest gift that we can give our teams is to enable them to fail fast, to fail often, and fail cheap. And I have seen firsthand, when we do that, we are in fact gifting them the feeling of empowerment and gratification. Thank you.